Hello everyone. So today I'm showing you one of my tools which I have created as a TimingVision Pro tool. This is a particularly STA tool which can help us to understand STA concept by their visualization, by their waveforms, and along with this, it is giving users so many unique features to understand STA concepts in a very easy manner. Along with this, it is having a multiple tabs operation, so it can perform so many things. It can help your ongoing type STA part, and you can see here that it is having some more tabs to go directly to that particular task. Along with this, uh, I have built some of the playgrounds in this tool. In this, you can play with the concepts and understand them. And in the bottom, you can see that some of the other tools I have provided in this major tool, which can help us to make this tool fully working. So this is the home page or a welcome page, you can say. In home page, you can see that key feature has been provided as a welcome note. So you can see currently it is supporting 11 key features. So we will go one by one to each feature. Then we have a current version. Currently, this is 21.8.0, and then we have a navigation bar as well to directly go to the particular task. And same, you can see we have some other tool support as well provided downside. So we will go one by one tab to see. So first tab is our waveform visualization. So okay, yes. So this tool gives us the understanding of our launch or capture flops, how our HTA concepts come on our launch or capture flop. So this tool or this tab will give us the information. So here we can see the clock polarities, the positive clock, positive to negative clock. As soon as we will shift, so here you can see the alignment, the orientation of clock will be shifted. Same with negative to negative as well as the negative to positive. So we will go by default positive to positive only. Here you can see that I have provided some STA concept. Suppose if I'm talking about setup time. So setup time we generally know that setup comes on the next cycle. So you can see the next cycle setup is coming. Same for the so for this setup one is coming here. Setup for this setup two is coming here. So like that, the here you can see I can collect I can select on select all. So you can see so it is plotting the stay concept, basic stay concept. But if we need further details, like if we want to understand what is setup time, like that, so we can go to help page. Here we can select the topic. Suppose if I want to understand clock skew. So you can see here. So what is clock skew? Clock skew is the differences of capture clock arrival and look. Then what is the formula and some kind of a plotting to give you a basic understanding, just like duty cycle. So here we can see ratio of clock high time to total period. How many? This is called the duty cycle, and here also same thing. So this applies to each topic. It's like for setup time also, setup time formula, and their plotting. So like that, we can close this. Okay. Then we have a particularly a section called STA concept animation. So this is the animation view of our topics. So this is a completely different window. This will demonstrate you the STA concept by animation. Just like if we are going anyone, just like if we are going for multi-cycle path, so you can see here that it is showing how the multi-cycle launch clock, multi-cycle cycle count, how many cycle count like this. So here we can see if we are talking about setup violation. So it will give us the understanding of setups like borderline and everything. Whenever setup is crossing, violating, whenever setup is our safe, like that. So if we are talking about clock jitter, so even we can increase or decrease the amount of jitter. So you can see here. So it is the clock is jittering with the value of 0.10 nanosecond. So like that, crosstalk as well. So clock strong victim and idle with respect to aggressive cross. So like this is the completely animation section where we can see like this setup and hold. So we can increase the setup and hold time. So this is completely a animation type with the understanding of the concept. So this is the one of the main highlight of this tool to understand to make user understand the topic. Second, we have a timing report analysis. So this tool help user to understand timing reports. So here, if I'm passing any timing report, so you can see here that this is a timing report having the setup data. So it is showing me that it is having the only one path, path one, only if one path is there. Okay, and it is showing that setup has been checked and it is violated. Okay, if I'm doing setup analysis, so it will analyze everything. What are the values available there? T combo, T skew, it will calculate, and then it can plot the data as well. This is the data has plotted by using the timing report which I have passed. So like this, it will come if I'm uploading any other report timing. So here you can see. Let me check. So here you can see in this timing report we have a three paths. If I'm clicking on this rest 25, if I'm doing for, so you can see that for this completely path two, our tool has been analyzed the setup timing analysis. And then if I'm doing setup plot data, so see, is also the data has been plotted properly. The clock, same it will apply to hold. So let me add the hold report as well. So we have a hold report here. So if I'm doing see, you can see here hold analysis for path one. So it is for violated hold check. So it is also showing me each data, calculating T combo, T skew, hold violation checks. And here also it is showing for path one all the data. If I'm doing hold also it is plotting. Okay. Along with this, uh, okay. So we have provided here the setup fix techniques. What are the techniques we are using for to fix setup? Same for hold. So you can see here. Currently it is static techniques, but in future implementation we can make as a dynamic by understanding the timing reports. Then we have a TNS and WNS calculation as well. So if I'm passing here TNS, total negative select, so it is showing me the total negative select is minus 92.384 nanosecond and three are the paths. And for WNS, you can see for WNS, this is the path where the most uh, worst negative path is available. So this is a completely timing report analysis window. For clock tree analysis, we will come later on. For violation, here in this window, we have provided the prediction violation analysis, like by putting the values in formula, we can see if our design will violate or not. So here in this video, in this formula, I am providing all the values: T hold, T combo, T setup, clock duty cycle, and everything. So if I'm clicking on predict uh, violation, so here by using putting the value only, we can see our setup time or hold time will violate or not. Here, the benefit of this is that I can change the value and again click on prediction. So it will tell me what is how the setup because I have changed the hold value. Here also you can see some diagram will come to understand user. Then we have another window is for explanation. Each term what how it will calculate or how it will affect the design. It is coming from here. Uh, we have a reset button as well. By pressing this, it will come to reset button. Then we have a debug console. So debug console is is a console where we are uploading our log file which we have generated, and then so this is the log file we have. So if I'm pressing on extract warning and error, so you can see here it is showing me nothing, but uh, we will see another file. See, not this one. This here in the log, I can pass any of the log file. So see, I have passed a new log file, loaded log file. So I'm clicking on this, so you can see here the warnings and error has been separated to understand more. This CMOS circuit implementation is in under development, so I'm working on this currently. Okay, and we will go to clock tree analysis. So this is the 3D model of how the clock tree will work to let user understand how from the source from the PLL clock is shifting from flip-flop buffer like this. So here I can add buffers here. You can see if I'm adding. So here buffers has been added. If I'm clicking on animate propagation, so it will show me how the clock is propagated from PLL to buffer 1, 2, and like this it is going from here to there. Violation analysis we have completed. Debug console we have completed. CMOS is in under progress for now. For advanced topic, here we can see that we have some advanced topic in our ST, just like CRPR, CPPR, antenna effect, latch up like this. So this here user can understand how CPPR, CRPR will come under the picture on the waveform as well, along with along with their explanation. So here for CPPR, common path pessimism removal. So we have the proper explanation and then our proper visualization. Same for CRPR, clock related CRPR concept. So here also you can see how the CRPR comes under the picture. Then OCV, on-chip variation, how the on-chip variation varies uh, with respect to uh, temperature and all things. So here you can see data nominal and this all things are coming here. Same with POCV, how the POCV chart will come for fast live, slow live, typical live or typical cells. Then AOCV here also there. I have created advanced on chip variation. It will give me the context aware variation mod based on the context aware variation modeling. So it will give me explanation and some of the visuals so that I can relate by the concepts. Same with crosstalk. What is crosstalk? How crosstalk affect the how the victim and aggressor works and how things will come. So we have electromigration as well here. Their explanation here you can see, and then their visualization. IR drop explanation, their visualization. Uh, latch up explanation, visualization. So this is completely visualization or explanation tool for a user. Then antenna effect, explanation, and their visualization. So this is some of the advanced concept I have provided. Then we have SDC validators. So this is completely a different tool where user will understand what SDC are. So we have some other SDC related tools as well with us, which will help us. So which will help us to understand SDC in more detail. So here, if I'm going, here I am providing the SDC commands. As soon as I'm clicking on SDC command, so you can see here that we have a window. So we should this, you know, I think there is some issue in this window. We will come back to this window later. Then we have CDC visualization as well. So from clock domain crossing, we can see here and we can visualize how the CDC will come with their analysis. There we can also provide different values. Just like if I'm pressing 2, 1. So you can see here, this is how the synchronized data will come for 2 clocks. Then we have a select tracker. So for that, we need particularly 2 timing reports. So timing reports are somewhere here. So timing report 1 has been loaded. We will load another one. So what it will do, it will let user compare the timing reports and their slack for better understanding or to make understanding more easier. So here we can right now compare 2 files, but in future we can add more comparison windows. So here we can see that from the load report one, from the loaded report one, we got this like -30. For second one we got this, and then we got the select comparison, and then what is the status, like has been improved or not. So it will help us to finish our STA. Then we have a critical path annotator. So here also we can see what is the critical path we are having in our timing report. All the data it is carrying with from the timing report only. So here, if I'm clicking on visualize, this is how it will visualize. TC to Q, how much time it is taking, T setup, how much time, critical path, uh, everything it will show me. I think I have covered more, but it's SDC. There is some issue with window. No. Yeah, yeah. Hi. So this button has been, I don't know why it came under that window. If I'm clicking on validate and visualize, so you can see it is showing me that I have added a create clock command with their parameters. If I'm clicking on see, so here you can see the clock has been came onto the picture. Just like if I'm clicking on constraint input output delay, so you can see here, and then the input output constraint also has been added. So this is how we can see how our data is working from the SDC, how our data is working properly based on the SDC. So this is the overview, or we can say short overview, short introduction about this tool. So now we will go to our sub tools, which are the supporting tools which I have provided in this. So we will go one by one. So first one is lib analyzer tool. By pressing this, you can see this lib analyzer has been opened. So uh, this tool I have created particularly to analyze the .lib input file which we have as an input to our PD or SDA. So we can load here any of the .lib file. .lib file here is somewhere. So you can see on console it is showing that file has been selected here, the file size. So this tool currently I have loaded as a version 1. So I have completed version 2 as well, which has been not aligned with this. So right now you can see here it is supporting only 5 to 6 per functionalities, but later on we can increase this. So by pressing our Liberty file itself, we can see that how many cells are present in our .lib file. So first operation we have as a standard cell libraries references. So here user can understand how how we are understanding our .lib file. So for .lib we have a lookup table. We are calculating input output delays and everything. So how we are doing all of these things, it is mentioned in these references. By this user can understand this. Second, we have a timing pin finder. So by clicking on this, if I'm clicking by running this operation, it will go to completely lib file and then provide me the timing pins which have the timing data. So if I'm clicking on this, so you can see it is calculating all the pins possible in this complete .lib file, and it will give me the count how many pins are there with the timing sense. So you can see here, so it is showing that 710 are timing pins. Then if I'm going for the delay type, it will check all the pins, how many delays are available. For timing, what we are doing, what we usually see in cell rise, cell fall, like this. So you can see here how many lines are this tool processing. So that's why this tool will help user to debug .lib file. This can help to reduce so much of time to understand a .lib particularly. So see for 2296 pins, it has been it has provided me the delay type. Then we have a timing analysis tool, so it is providing the timing analysis data for obviously for all the 700 pins, timing pins, 710 timing pins. So I can cancel it because yes, we know. Then we have a power pin. So it will give me how many pins are related to power in our .lib file. So here also we can see it has been provide me the count 1306, but along with this it is giving me the pin name as well. So yes, 612 power pins has been. So you can see here power pin has been came under this dashboard, and then we have a power analysis tool. So it will give me the rise power, minimum, maximum, or fall power if there is. So you can see here that for particular pin, rise power, value and max value both are present. And whatever data we are extracting, we can extract to this as a export file. So it will export all six uh, CSV files for this. and then for same as well for PDF. Uh, So it is under output PDF export. So we'll go to particularly in this directory. Is, yes. So we can see here PDF exports. You see it is giving me full summary, data prints, all the data. Some data has been corrupt, not properly correct. Will I will check that. Or for CSV export, all the CSV has been generated for all the data. If I'm clicking on timing delays, to see how the output will go. Pin name, timing sense, condition for cell fall min, cell fall max, cell rise min, cell rise max, fall transaction. If any of the pin doesn't have any of these out of four, so it will come as a zero. I will show you. So you can see here. So like this, it will come. So this is one of the tool which is supporting main tool. Here we have some utilities option as well. Version help clear outputs. Console will be created clear here. So log file will be just log file always. You can see whatever operation we are doing here. For that we are having log file as well. Same for report. So report also has been created for each task which we are doing here. So this is the one tool. Second tool we have as a go to Innovus user guide. So this is also a under development tool. I am creating a user guide for Innovus while learning Innovus. So this user guide will this is a completely HTML based web page. So here on the basis of our stage we can see how many commands we can use in our Innovus. So like that it will come like this. And suppose if I'm going as a head add fillet cell or cell name, I'm clicking on this. So you can see here it will give me a syntax how to use that. Its uses, its stage, and its after effect. So directly I can copy this command or copy their syntax to use that. So this is the tool. This is also Innovus user guide which is under progress and which will support this tool, TimingVision Pro. Then we have same for synthesis. So synthesis also for synthesis also user guide is there. How many commands uh, we are using for genus. For logical synthesis, how many commands are using? We are using read HDL, optimize HDL, like this, set vision. So like this. And then for physical synthesis, for constraint optimization, so like this, we have synthesis reference. Then we have RTL to GDS file format. This is also one of the supporting HTML doc which I have created. So what this tool will help? This tool will give user complete overview of how many types of file we are generally used at each stage from RTL to GDS. So you can see here if I'm going for synthesis, so synthesis it will give me all the files just like get level verilog dot lib is one of the input, SDC is one of the input, UPF is one of the input. So like this, if I'm going for placement, so def, lef, fef, SDC dot tex file technology file dot db. So for each file, if I'm going for suppose for SDC, so I'm clicking on details. So it will give me who prepared that advanced. Yes. Sorry. at which stage, what are the tools uh, for this SDC has been used, and how SDC will look like. So this is also one of the tools. Then we have this SDC tool. This is uh, again a Python based tool. In this tool, what it is happening here is that this tool will help user to understand SDC in a better way. Here, user first need to add the manual pages where all the manual pages are present. Here, along with this, you need to add any of the SDC files. So if I'm adding this SDC file, so you can see after adding only, it collected all the commands present in this particular SDC. If I'm clicking on anything, just like for set output delay, if I'm clicking on this and clicking like explain command, so you can see here that it will explain me what this command does. I can change from set output delay to any of other command. Say if I'm going for set input delay, I'm going set input command. It is, and the unique thing is that you can see here what are the command written here. It is same. They both are same, and this tool is trying to give the explanation in respect of this command and their argument and as well as parameters both. Still, if user is not clear, then we can go to command manual. So as you can see, we were on the set input delay. Here directly we went to set input delay manual page. So like this. So this tool will help user to understand SDC without opening Genus, or if we have a SDC very big size, so it will give user so much information. And then we have also command frequency. So how many commands is present in this file, their frequency or their count. So like this, we have some more tool. I think the video will be that much big that. So thank you for quick demo. Thank you for understanding this topic. We will connect. Let me know if you have any doubt. Thank you, everyone.